In this particular session, we are going to deal two questions at one go. And one very important point, I have been always telling, when you go through a paper, as you read the question, if you get the answer, take it straight. If you don't, go to the next. So when I said last time that you must finish your 60% paper within first 30 minutes, that is what I meant. You read the question, you get the answer, take it and go straight. If you can't get that way, go to the next question, go to the next question. Why I am stressing on this point, in NEET 26, the copy of the session, that particular paper I have, these two questions, which you can answer even while sleeping, even in sleep, are appearing as last 5 questions in chemistry paper. Now, if you get stuck initially and don't read the whole paper, the method I told you, and get entangled in earlier questions, in my life, I have come across many of my students telling that they knew the answer, but by the time they reached, the time was over. So that is why I said you always read the question answer and go to the end before coming back for the second part. Now, these two questions came at the end, and see how you can give the answers without any calculation. First question: in which of the following Kp is not equal to Kc? I'm sure you know that Kp is not equal to Kc depends on delta Ng, where delta Ng is difference between product and reactant moles. If delta Ng is equal to 0, then Kp is equal to Kc. In this question, what is asked is, in which case Kp is not equal to Kc? So all that you have to look, in which case delta Ng is not 0. I will start with first equilibrium. They are all famous equilibriums. I always quote 7 equilibriums which are always asked, and these are the 4 equilibriums which have been asked very regularly in exam. The first equation is H2 gas plus I2 gas is equal to twice HI gas. Left side 2, right side 2, delta Ng is equal to 0, Kp is equal to Kc. You are asked which case Kp is not equal to Kc. So A is not the answer. B is Haber's process. Remember, these are very famous Nobel Prize winning reactions that you are supposed to know. But I'm going to give you the equation. That equation is N2 gas plus thrice H2 gas is equal to twice ammonia gas. This is an equilibrium which gives us food. Sometimes later on I will tell you what is the importance of this reaction and why it was given Nobel Prize. Now in this case, you see N2 plus thrice H2, reactant 4, product twice ammonia 2. Very good. Delta Ng is not equal to 0. So this is the answer. I will give you third and fourth equilibrium also to tell you that in that case, you will tell me. N2 plus O2 gas, N2 gas plus O2 gas equal to twice NO gas. Again, delta Ng 0. Kp is equal to Kc. This is not the answer. Already the answer we have seen, B. So, this is how you do these particular things. Now, let us go to the next question. Delta, they make you any of the equilibrium. You know what you have to do is delta Ng. I have given you just 3 equilibriums here. The fourth equilibrium was not about the gases, it was different thing. So we'll do it with something later on. Now we go to the next part. Now this is about the ligand, transition metal and coordination chemistry. Any time the question is asked, now there are many questions from transition metal and coordination chemistry which require detailed knowledge of so many things. But this question which is asked doesn't require anything. Question is, which of the following is ambident ligand? Ambident ligand is the ligand which can link from 2 ends. In pure Hindi, sometimes it is called do muha ligand. From which end it will catch up the metal is not known. That is why it is called ambident. It is very similar to the English word what is called ambiguous. Ambiguous means you're not sure. ये भी हो सकता है, वो भी हो सकता है. This can happen, that can happen. Now the ligands given are EDTA. You're sure you don't know, you know that it is not this thing. Ethylene diamine, this is also not this thing. It can be from only one way. Then acetate, only one way. And the answer, thiocyanate. As soon as you see thiocyanate, there are only 4 or 5 ligands which are normally asked. Cyanide, isocyanide, cyanate, thiocyanate. That is cyanate, isocyanate, thiocyanate, isocyanate. Thank you.